Today we're diving into what I think is a massive, synchronized breakthrough that finally, and I mean finally, fixed literally the most annoying bug in local AI. Seriously, if you've been running models on your own hardware lately, you know exactly what I'm talking about, right?
So why does your local AI setup keep stalling out mid-task? You know the drill. It's that classic scenario. You give your local assistant a complex job, and it starts out strong, and then it just completely abandons the task halfway through. Or actually even worse, it confidently hallucinates a done message when the work isn't even close to finished. This has been a chronic, hair-pulling issue for developers and power users alike. But this week, well, everything kind of changed.
Section 1. 2 updates, 1 fix. The dual-engine solution.
The solution we're looking at isn't just a single, simple software patch. No, it's a dual-engine fix. And honestly, it's incredible how perfectly timed these two releases were. On one hand, we've got Ollama's version 0.32.1, which dropped on July 18th. This update specifically hardened Gemma 4's tool calling capabilities. Basically, it forced the AI to actually complete its response after using a tool, rather than just dropping the ball. But hey, that's only half the story. Over on the other side, just 3 days earlier on July 15th, Google quietly, and I mean quietly, refreshed the actual Gemma 4 model weights on Hugging Face. They kept the exact same name, but under the hood, total upgrade. Google added Flash Attention for support, which is basically a massive memory optimization for NVIDIA GPUs, smoothed out the chat templates, fixed tool calling reliability directly inside the model's core architecture, and even cleaned up its vision and OCR results. So yeah, it's not just the Ollama wrapper that got upgraded, the core model itself evolved.
So here's the absolute crucial point you need to take away from this. If you pulled Gemma 4 before mid-July, you are running on an outdated cache. You are completely missing out on the core fixes Google implemented. You absolutely must clear your cache and repull the model right now to get these benefits. Seriously, go do it.
Section 2. The numbers don't lie. Benchmarking the jump. Now, software release notes are great and all, but the actual data brilliantly illustrates the crazy leap we're talking about here. Take a look at the Touchbench test, which basically evaluates how well an AI can actually use tools to function like a real autonomous assistant. Gemma 3, it scored a dismal 6.6% on this test. It was practically useless for complex workflows. But then, look at Gemma 4 shooting all the way up to 86.4%. That is an explosive, unprecedented jump. Now, even with that high score, users were still reporting that the model would initiate a tool call and then just failed to finish the overall task. That gap, that specific annoying point of failure, is exactly what the combined Google and Ollama updates have finally sealed shut.
Section 3. A real MacBook test. Putting the chain to work.
Okay, so we have the benchmark numbers, sure. But how does this actually hold up in the wild? Well, right after Ollama version 0.321 dropped, tech writer Pankaj Yadav ran a brutal stress test on his MacBook Air. He used MLX, which, if you don't know, is Apple's framework optimized for their own silicon. And he didn't just give the AI some simple hello world prompt. Oh no, he fed it a messy, complex, 400-line Python script filled with nested error handling. We're talking the kind of spaghetti code that literally makes human developers cry. He really wanted to see if the AI would crack under pressure like it used to. The prompt demanded a rigorous, continuous chain of actions. First, find 3 performance bottlenecks in the code. Second, rewrite those slow spots for speed. Third, execute tests on the new code. And fourth, generate a clear final report. In the past, this exact workflow would just shatter halfway through. But with the new dual-engine fix, the AI flawlessly followed the entire chain. It found the spots, rewrote the code, ran the tests, and delivered the report, all in one single go. This isn't just some marketing claim from a tech giant. It's validated real-world execution running on a standard laptop. How cool is that?
Section 4. The speed advantage, multi-token prediction.
Alongside this newfound reliability, we've also been handed a massive upgrade in raw speed. To really understand it, we kind of have to look back just a few weeks to June 29th. That's when Ollama released version 0.31, an update that made multi-token prediction the default for Gemma 4 on MLX. Think of how your mobile phone's autocomplete guesses the next word you want to type, right? Well, multi-token prediction is like that, but on steroids. Instead of generating just one single word or token at a time, the AI is simultaneously guessing 3 to 4 words ahead. It lays the absolute perfect groundwork for incredibly fast output.
So, what does that actually mean for your processing times? Well, on the Ader Polyglot benchmark, which is a highly respected real-world coding test, the speed rocketed from 50 tokens per second up to a blistering 95 tokens per second on high-end hardware like a Mac with an M5 Max chip. And honestly, the best part? This June speed update stacks beautifully with the July 15th reliability refresh. You're getting nearly double the speed with absolutely zero drop in task completion.
Section 5. The big picture. What this means for your workflow.
Okay, let's bring all this technical data down to earth for a second. What does this big picture actually mean for your day-to-day workflow? Basically, it means that highly autonomous, single-run workflows are now a reality on local hardware. For example, you can ask the AI to write a sign-up form for your website, and it will now independently test the fields and fix its own errors with drastically reduced manual oversight from you. Need some community management done? You can literally have the AI generate 5 different weekly welcome messages, automatically select the best one, and save it directly to a specific file, all in one continuous run. And because of the tool calling fixes we talked about, it can finally navigate complex, multi-file projects accurately by actually recognizing its current directory, severely cutting down on those frustrating navigation errors.
If we look back just 1 year ago, the landscape was entirely different. I mean, if you wanted reliable tool usage back then, you were fundamentally reliant on expensive cloud APIs. You had to send your proprietary data out over the internet. But today, thanks to Ollama's continuous wrapper fixes and Google's quiet model refreshes, you have 100% local, secure, and autonomous execution. Your laptop can now plan a task, use its own tools, check its own work, and finish the whole shebang completely offline.
So, my advice to you? Skip the simple, isolated demos. Clear that old cache, pull the newly refreshed Gemma 4, and test this dual-engine fix on a real, messy codebase of your own. Push it to its absolute limits and see the unbroken chain of logic for yourself. I promise, you're going to be impressed.
But I want to leave you with a final thought to ponder as we wrap up this explainer. As these local models become faster and just incredibly reliable, our need to manually check their work is rapidly decreasing. It feels like magic, for sure, but it's kind of a double-edged sword. As manual checking decreases, are we beginning to trust these tools a little too much? The friction of failure used to force us to review the code. Now that the friction is gone, we have to make sure we're still managing the AI and not just blindly letting it run our systems. Think about how that changes your relationship with the software you write.